Good morning students. Today we are going to discuss about some basic concepts of radiation. We know that the heat transfer is somewhat different from engineering thermodynamics. In thermodynamics, it deals with the equilibrium states, but in heat and mass transfer, it deals with the non-equilibrium states. So, a driving force for heat transfer is the temperature difference. So if the temperature difference occurs, then only the heat will be transferred from one medium to another medium. So to transfer the heat transfer, we need three mechanisms. First one is conduction and convection and radiation. So for the first two mechanisms, we need a material medium to transfer heat. But for the third mode of heat transfer, that is radiation, we don't require any material medium to transfer the heat. So we are more concerning about the thermal radiation. So the thermal radiation will be transferring by electromagnetic waves in the form of electromagnetic waves. So in the electromagnetic waves will transfer through the medium at different velocities. So we can categorize or classify various types of electromagnetic waves depends upon the wavelength. So from the wavelength we can categorize as different waves. The first characteristic of electromagnetic radiation is all solids and liquids, irrespective of its temperature, will emit thermal radiation. Whether it is higher temperature or lower temperature, all the solids and liquids emits thermal radiation. So if you want to know the quantity of emitted radiation, then we can use the Stefan-Boltzmann law. So from this law, the rate of heat transfer per area will be directly proportional to the fourth power of temperature. So the temperature in Kelvin. So this is the absolute temperature. So this is the heat transfer per unit area. So in this you can see the spectrum of electromagnetic waves. So in this we are only concerning about the thermal radiation. So the thermal radiation exists in the wavelength of 10 power minus 1 to 10 power 2 microns. So the visible light will also exist in this thermal radiation wavelength only. So in the higher side, that is from 10 power 2 to 10 power 6, we are having microwaves and radio waves. So in the lower side of wavelength, you are having X-rays and gamma rays. The X-rays are from 10 power minus 2 to 10 power minus 4 microns, and beyond that we are having gamma rays and other electromagnetic waves. So we are only dealing about the thermal radiation, which is having the wavelength of 10 power minus 1 to 100 microns. So this is the second characteristic of electromagnetic waves. So the surfaces which is having the capacity to absorb radiation by the surrounding surface. For example, we can take the surface A here, okay, whether it is plane surface or a concave or convex surface. So which is surrounded by so many surfaces. That means you are having surface 1 and surface 2 and surface 3. So irrespective of its configuration, that is geometrical configuration and angles from the surface, it will absorb the radiation from all the other surrounding surfaces. We know that all the bodies which are having the absolute zero temperature will emit radiation. Whether it is a solid or a liquid will emit radiation. So here we are dealing with one important characteristic of the surface. So surfaces which have higher temperatures emit radiation than absorb and reflect from other surfaces. For example, we are having an enclosure. The temperature of the enclosure is TE. So in this enclosure we are having a solid surface. So the surface is A, then we can name it as A. The temperature of this solid surface is TS. Assume this solid surface which is having a higher temperature than the enclosure temperature. So in by our concept, the solid surface A will emit more radiation than it reflects and absorbs from other surfaces. That means Ts is greater than Te. So this is the special characteristic of the surface. So this is the fourth characteristic of electromagnetic waves. Suppose we are having a surface, so we can call it as B. So this surface which will emit radiation in all the directions. So this is a directional nature of the directional characteristic of the electromagnetic waves. So if you draw a profile of all these emitted radiation, it will be a hemisphere. So this is the fourth characteristics of the radiation, electromagnetic wave radiation. So in this manner, the radiation heat transfer will occur from the surfaces. Thank you.